How do we measure emissions in power production? This is now the discussion. You are very welcome to participate in this session. My name is Merja Mäkelä. When fossil and renewable fuels are combusted in a furnace, flue gases with emissions are coming out. You remember that some fuels make harmful and toxic emissions, others don't. In the flue gases, we get mainly nitrogen, carbon dioxide, water as steam and oxygen. In addition, we get some carbon monoxide, sulfur oxides, nitrogen oxides, hydrocarbons and particulate matter. Anyway, we like to know which emissions are coming out and how much emissions we are getting in the flue gases. Online, in situ analyzers measured continuously directly in stacks. You see those yellow measurement instruments in the stack. In offline measurements, samples are taken periodically and separate analyzers are used. The automatic drying of the sample in the cabinet is an important pre-processing procedure. Different kinds of technologies are used for emission measurements. Infrared light, ultraviolet light, chemiluminescence phenomena, and visible laser light, for example. Based on infrared light, we are able to measure sulfur dioxide, nitrogen oxides, carbon monoxide, total organic carbon, hydrogen chloride, hydrogen fluoride, and water. Infrared analyzers are based on Fourier transform infrared spectroscopy. The studied gas is irradiated by infrared light, and the absorption spectrum is measured and compared to the spectrum library data. An FTIR analyzer arrangement could look like this example. The measurement probe is in the stack and the sample is pre-processed and analyzed in the cabinet. We get the measurement results to a control system. Based on ultraviolet light, we are able to measure nitrogen dioxide, sulfur dioxide, and hydrogen sulfide, for example. Hydrogen sulfide warns us with its smell. An ultraviolet measurement arrangement comprises an ultraviolet source, a filter unit, a beam splitter for radiation, a measurement cuvette, and a reference cell. Gases have specific absorption characteristics. The absorption of studied gas is measured and compared to the reference cell absorption. Nitrogen oxides can be measured based on chemiluminescence. Nitrogen oxides cause a chemical reaction in the measurement cell, and nitrogen dioxide-related light will be generated and detected. Laser light can be used for the measurement of particulate matter. A studied gas is irradiated by visible laser light. The intensity of backscattering is related to particulate matter concentration. Next, you will get some practical advice for continuous emission measurement systems. Firstly, define the process parameters, components and measurement ranges. Secondly, classify the valid regulations and directives. Thirdly, be aware of possible new regulations. In number 4, make clear the on-site operation conditions. In number 5, find out the potential sources of critical gas components. In number 6, assess the operation conditions for the whole life cycle of a CEMS. In number 7, remember to calculate operation costs. In number 8, figure out maintenance requirements. In number 9, check on-site access conditions. Finally, evaluate the capacity of the supplier candidate. According to the norm EN 14181 for emission measurement systems, there are 3 quality assurance levels: Quality Assurance Level 1, Quality Assurance Level 2, and Quality Assurance Level 3. The first quality assurance level is mostly related to CMS suppliers. It stated, for example, that the total uncertainty of a CMS has to be smaller than the requirements of authorities. The second quality assurance level discusses functional tests, calibration and validation of continuous emission measurement systems. The third quality assurance level deals with the practical operation and maintenance of continuous emission measurement systems. In situ and extractive measurement analyzers are used for the measurement of flue gas emissions in power production. The analyzers must fulfill the requirements of authorities and power production companies. Thank you for your attention.